and what's up, engineers? For today's video, we will explain the science documentary of Richard Hammond, which is all about the significance of supertankers and its engineering connection. So come on, let's fire it out! Richard Hammond's science documentary, Supertanker, demonstrates the brilliance of engineering by transporting a cargo of liquefied natural gas. This video is essentially a documentary about a supertanker transporting thousands and thousands of liters of liquid gas all over the world. And Mr. Richard demonstrated the role of engineering and how an engineer should understand chemistry in order to do this successfully. This video explains the engineering behind the supertankers. Supertankers are some of the world's largest and most complex ships, and they require a great deal of engineering to function properly. Designing a tanker for one of the world's most dangerous cargos presents a number of engineering challenges. It must be able to withstand the ocean's harsh conditions, such as high winds and waves. It must also be to navigate through congested shipping lanes safely. The tanker must also be capable of quickly and efficiently loading and unloading its cargo. Despite this, they were able to create a vast sophisticated machine using ancient technology, inspiration from cutlery, mid-air refueling, and fire engines, as the documentary emphasizes. The supertanker is an excellent example of the benefits of technology and innovation when done correctly, and it is clearly no easy feat. This video supertanker episode of Engineering Connections showcases an intriguing look at the challenges and variety of engineering feats involved in the construction of a massive sea vessel. The supertanker has a width of nearly 400 feet and can carry up to 2 million barrels of oil. It has a depth of nearly 70 feet and a height of nearly 100 feet. The tanker can travel at 15 knots and has a range of 9,000 nautical miles. Overall, this video delves into some of the most critical engineering aspects of supertankers, such as their hulls, engines, and ballast tanks. The design and construction of an LNG supertanker, a massive ship larger than the Titanic, is showcased in this episode of Engineering Connections. Developing such a technology, as previously indicated, is extremely difficult. As an alternative to the costly pipelines, this tanker can hold a much larger amount of natural gas than traditional tankers, making it more efficient and capable of transporting more packages at a time. The supertanker has 4 tanks, each of which can hold approximately 34 million liters of liquid gas. It contains liquid natural gas, which reduces the volume by 600 times and the length of the ship by 10 times. When exposed to atmospheric temperatures, natural gas will ignite. With a single small leak, the supertanker can explode with the energy of 55 atomic bombs. The crew of the supertank, on the other hand, has been very careful to maintain safety precautions on board, such as not allowing electronic devices at certain points near the tank. There have also been several lines of defense in place to prevent unwanted ignition. To begin, keep the tank cold to keep the natural gas in a liquid state that is not flammable. Another advantage is that it requires much less volume than gas. What if there is a leak? We know that at any temperature above negative 162 Celsius, the liquid turns to gas and may explode. As a result, they devised a second defense or innovation inspired by air-to-air refueling.
To prevent explosions in the aviation industry, nitrogen, an inert gas, is used. As a result, the tank is sealed with a porous insulator steeped in nitrogen in the event of a leak. Another engineering challenge is the cold temperature. Some metals become brittle and easily break at cryogenic temperatures. To address this issue, They were inspired by cutlery made of stainless steel with chromium, which can withstand extremely cold temperatures and is extremely tough. The strength of this alloy is tied to its outer crystal structure, which makes it more durable. Another challenge is preventing the cargo from sloshing as a result of the large free surface. Sloshing can be disastrous because it can cause the entire ship to capsize during a storm, making the tank spherical, which reduces surface area and ensures the tank is very filled of empty during transport, was one solution considered by the engineers. Baffles inspired by fire trucks are also used to reduce surface area and thus sloshing. Consider the amount of power required to propel such as massive tanks. The key is Hero's engine, a massive engine based on a principle used tens of thousands of years ago. The tanker is propelled by a steam engine which turns the propel and generates electricity for the ship by using seawater. This method is extremely efficient because it boils water at a low temperature by lowering the pressure. This is accomplished by rapidly condensing steam into a water. Chemistry theories are the hard complex technologies, and this video is an excellent study of chemistry for engineers because it is intertwined in the solutions used to transport the precious cargo efficiently. We begin with chemistry for engineering teaches the various properties of gases, which is why we knew the natural gas ignites at the atmospheric temperature, and also learned about the benefits of nitrogen despite being labeled as a noxious gas. So, using nitrogen to stop an explosion is also related to chemistry because nitrogen is inert. It does not react with anything. That is why in chemistry, we become acquainted with the periodic table and compounds in order to identify the benefits and drawbacks of using them. Furthermore, it teaches us about melt combinations such as the addition of chromium to steel to produce stainless steel, which is non-corrosive and ductile at low temperatures. Alloys are metal combinations that are discussed in various chemistry lessons, so that in higher engineering such as design, we can choose the best material for the job. Second, in returning to the state of matter of natural gas itself, we learned in chemistry that liquid takes up less volume than gas, making liquefying the natural gas necessary. Third, it teaches us about the pressure-temperature relationships. As mentioned in the video, as altitude increases, pressure decreases, making it easier to boil water at a low temperature. This is used in a lot of technology to keep the material from overheating. Fourth, a branch of chemistry known as thermodynamics will teach us how to use our chemistry knowledge to generate energy and work. To create complex technologies, we must first master all of the fundamental theories. To summarize, chemistry is closely related to everything from discovering an alloy with a significant chemical structure to harnessing the power of engines.